Hello everyone. For my project, I chose to focus on water filtration. Lately, the news has been abundant with stories about contaminated water. Entire towns, like Flint, are being poisoned by their own water supply. Hearing these stories made me curious to learn about alternative methods of purifying water. I conducted research into this matter and found various solutions. One such method of purifying water works by vapor compression distillation. This system is quite old and is utilized by drug companies in the U.S. Navy. It is also utilized by the Slingshot water purifier. Slingshot is a purifier about the size of a mini fridge that can purify nearly any water source, including the ocean, water laced with arsenic, poison, heavy metals, viruses, and bacteria, liquid at a chemical waste site, or the contents of a latrine. The device was created by Dean Common and works by boiling and reliquefying water. Dirty water is sucked up by the device's hose, and then the water is heated to its boiling point, 212 degrees Fahrenheit. The water then enters an evaporator where it is heated some more and boils. This removes some contaminants because anything that does not boil at this temperature, like stones, dirt, and salt, are left behind when the water is drained. Bacteria, viruses, eggs, and spores don't rise with the steam in the evaporator and are pasteurized by the heat in the purifier. Once the steam rises, it moves into a compressor where the temperature is raised above 212 degrees. The steam moves into another chamber where the walls are heated at 212 degrees, and this filters out some more things. Anything that boils below 212 degrees, like benzene, remains a gas and is released. This allows only pure water to condense on the walls. The clean water then drips into a final chamber where it is ready for use, only it is too hot. The water is cooled using a counterflow heat exchanger. Incoming and outgoing streams flow past one another. This heats incoming water to 212 degrees while cooling outgoing water to the outside temperature. The slingshot sounds like a great method, but is neither practical nor suitable for all communities, especially the ones who are in desperate need of it. For starters, it runs on electricity. Granted, it only requires 1 kilowatt, but this can still be an issue for some communities. However, the device can plug into outlets and diesel generators, but it can also utilize Stirling engines. Stirling engines use heat and cold to expand and compress a gas to make pistons pump. Nearly anything can be burned and used to produce the necessary heat, like kerosene, methane, even cow dung. Additionally, the air can be used as the cold source. This means that it could practically be used anywhere. Another method involves solar stills. Solar stills are useful when other water sources are unavailable, such as during power outages, during a hurricane, in remote areas with a loss of electricity, or in the event of a wilderness emergency. A simple solar still can be constructed by digging a hole in the ground, placing a container that can hold water in the middle, covering the hole with a clear plastic sheet, and putting a pebble on the sheet directly over the container in the middle. The plastic will trap the sun's rays, producing heat. The moisture within the hole will evaporate and condense on the underside of the plastic and run down into the container. Here the water will collect and you have fresh, clean water. Yet another method is SODIS, which stands for Solar Water Disinfection Method. It is cost-effective and useful in producing safe drinking water in developing countries. Clear PET bottles are filled with water and placed in the sun for 6 hours. The UVA rays and sunlight kills germs such as viruses, bacteria, and parasites. This process works even in lower temperatures. Numerous research studies have been conducted confirming that the method effectively kills germs in water. Inspired by my research, I decided to conduct an experiment in which I would test 3 separate filtration methods to see which method works best. My purpose in conducting this experiment is to find an inexpensive, effective water filtration method that can easily be recreated in areas desperately in need of clean water. The materials I used included 3 soda bottles, 1 juice bottle, a pair of scissors, tape, hot glue, yarn, construction paper, 2 lava lamp bulbs, tin foil, contaminated water that I created by adding dirt and soil to a container filled with water, 1 coffee filter, charcoal, gravel, grass, and plant leaves. The first method involved the traditional filtration system. I took a soda bottle and cut it in half. Then I took the half with the opening, turned it upside down, and began packing the filtering materials in. I started with a coffee filter, then I placed a circular disc of charcoal in the bottle's neck. Then I put a layer of grass, which I collected from my local park. Next, I put a layer of gravel, which was collected from the park as well. I put this on top of the grass level. After this layer, I placed a bunch of thick, wide leaves, and then to top it off, I placed another layer of gravel. Then I took the top half to rest within the bottom half. For the second method, I took a juice bottle and yet again cut the bottle in half. I took the bottom half and filled it with 2 cups of contaminated water. I then took the bottom half and placed it atop a box for height. Next, I took the top half, with the cap still fastened, and turned it upside down so it can act as a bowl, and then placed it at the base of the box. Then I took a length of yarn, placed one end in the contaminated water, and draped the yarn over the side and down into the container at the bottom. The theory behind this method is the yarn should absorb the water, leave behind particles and other contaminants, and then the water should travel the length of the yarn and pool in the bottom container, clean and filtered. For the third method, I used 2 soda bottles, 2 water bottles, a Sharpie, hot glue tape, and the bulb from the lava lamp. First, I cut the top and bottom off both of the water bottles. Then I used the Sharpie to trace the outline of the water bottles onto the soda bottles. Next, I used scissors and a box cutter to cut out the circles from the soda bottle. Once that was completed, I packed the 2 water bottles into the newly made openings and used hot glue and tape to secure the bottles in place, making sure to create a tight seal. Next, I traced the outlines of the water bottles onto the other soda bottle, which was turned in the opposite direction. Once again, I cut out openings and tightly secured the ends of the water bottles in them. Afterwards, I take the base of a lava lamp and fasten it so it can angle down and shine upon the bottle. Next, I took black construction paper and wrapped 1 soda bottle with it. Then I poured 2 cups of contaminated water into the covered soda bottle and used a few books to prop the bottle so it could sit level. The concept behind this method is the light acts as a stand-in for the sun. I wrapped the bottle in black so it would absorb more light and heat. In theory, the contaminated water should evaporate within the bottle, move across the water bottles, and collect in the empty soda bottle where clean water will pool. This method was inspired by my research on solar cells and partly because of the slingshot purifier. Now it is time for me to discuss my hypothesis. For the string method, I did not think it would work. On a small chance that it did work, I predicted that it would take a long time, and even then there would be a little amount of water. For the light method, I was not at all confident that it would work, but I thought I'd give it enough time that it may. For the filter method, I hypothesized that it would work fast, but the water might still be slightly murky and not that clear. Now I shall discuss my results. I set up each method on the same table and initiated the experiment at 1:10 a.m. Almost instantaneously, the contaminated water flew through the layers of the filter method and collected at the bottom. Within a few moments' time, all the water had pooled at the bottom. After going through this process, the water looked cleaner. There were no particles, and it looked clearer, and it only had a slight yellow tint. Since this method worked faster than expected, I decided to filter the water again. So I emptied the water into another container and poured it back through the filter. Only this time, there was a noticeable difference. During the second time, the water flowed much slower, and it took longer for all of it to collect at the bottom. I concluded that this was due to all of the particulates and contaminants filtered out the first time. After being filtered out, they must have clogged up the system, causing the water to run slower. Once all the water was finished collecting, I observed that the water seemed clearer than the first time. The quick instant results I got from this method would not translate to the others. For the string method, after roughly an hour of no progress, I decided to add another string, this one white. The white string was thicker than the gray, so I thought this change might prove more effective. When I checked back on the progress after 12 hours, I was surprised to see no progress at all. At this moment, I began to make additional adjustments. Firstly, I moved the bottles to a new location. Initially, it was set up near the other methods, so I thought the light for the light method might be adversely affecting the results by keeping the string warm and dry. Secondly, I added 2 different types of string, one that was thin and strong, and another that was more ribbon-like. Thirdly, I changed the height of the raised bottle. I lowered it to see if that might prove more beneficial. Fourthly, I wet the full length of each string in order to jumpstart the process. I predicted that doing so would allow the water to soak up and travel easier. When I observed the progress 12 hours later, I discovered that a caps full of water had collected, and I could see a stream of water leading from the ends of the strings to the water collected in the bottle. All of the strings were working except the ribbon, which had dried. I assumed the ribbon was ineffective because its fibers are different than the others. Additionally, the smooth synthetic texture might allow it to dry easier, making the transfer and absorption of water much more difficult. The experiment continued for 2 more days, during which time the water continued to steadily transfer from the raised container down to the bottom one. After traveling across the string, the water was much cleaner and clearer. There was no floating contaminants, and it was clearer than the water that passed through the filter. For the light method, progress was slow as well. 36 minutes into the experiment, I observed no change, but it was at this point that I realized I forgot to fasten the cap. After placing the cap back on, I realized that any condensation that occurred would have exited the bottle instead of traveling to the side of the empty bottle. After some time, I noticed slight condensation forming on the inside of the bottle, but no pooling. When I observed the progress after 12 hours, I found no signs of progress. The slight condensation seemed to remain consistent, but there was no progress. It was at this point I decided to make adjustments. I removed the black construction paper, thinking that this might allow the water to heat up more. I also moved the setup closer to the light source. I also dropped a dark towel over the empty bottle in order to shield it from the light. I thought the water on that side might be drying up from the light's heat, so I covered it in order to prevent this. I allowed these changes to work for 12 hours as well. After 12 hours, I observed a noticeable increase in the condensation against the bottle, but there was still no pooling. I allowed the experiment to run for an additional 12 hours, at which point no observable progress had been made, although the condensation remained constant. Here, I decided to make additional changes. I added another light source, and I placed a sheet of tinfoil beside the bottle filled with water, so some of the escaping light could reflect and directly hit the water. After another 12 hours, there was an observable increase in condensation. It was more widespread, and the droplets on the side were much larger, but there was still no pooling, although the increase in condensation did prove hopeful. When the results were examined 12 hours later, the condensation level looked constant, but there was now some pooling. About a cap's worth of water had collected in the bottle. The experiment went on for 12 more hours, at which point the condensation level persisted and the amount of water collected increased slightly. In conclusion, all three methods were effective to some degree, but they were not all equal. The filter method was by far the quickest method, but the water was also the dirtiest of the three. Much was filtered out in the process, but the water still maintained a slight yellow tint that was darker than the other methods. The light method was the longest method, and it produced the least amount of clean water, but this water was in fact the cleanest of all three. This makes sense since as the water underwent condensation, much was left behind, so when the water pooled again, it was very clear. The string method took a long time as well, but it was not as long as the light method, and it produced more clean water. This water was clearer than the water from the filter method, but not as clear as the light method. After examining the results pertaining to the light method, I began questioning how the results would have changed had I used the actual sun instead of my light alternative. Would the results have differed, or would they have stayed the same? I also began questioning how the results would have fared if the water was boiled. If the water had been boiled, the heat would have killed off bacteria, and perhaps condensation would have collected and pooled in the empty side much faster, thus creating more clean water faster. After examining all the results, I've concluded that the filter method would be the most practical and efficient method when one is in desperate need of clean water. Although it didn't get the water the cleanest, it got it pretty clean, and the method's speed compensates for that. So if one does not have time to waste, this would be the best choice. If time is not a concern, I would then suggest the string method. It may take some time, but it is effective. I might also suggest a hybrid between the filter and the string method. By combining the two, you can produce really clear water in a respectable time. By conducting this experiment and completing this research, I really gained an appreciation for how precious clean water really is. Living in America, it's easy to forget how privileged we are that we have such access to clean water that we don't have to think about it. It's not a concern for us. We are lucky in that way, so it's easy to take that for granted. Other people living in other countries aren't so lucky. They have to worry about the water they drink. Some people don't have access to clean water. This really gave me an appreciation for that, and really made me empathize for those less fortunate that don't have instant access to clean, healthy water. So if this research can help in any way, then great. Thank you.